Hello there, this is Mr. Bainey, and lesson 7.2 is using functions to solve one variable equations. The essential question is how can you use functions to solve one variable equations? Let's do this exploratory. Let's take a look at it. Susan wants to hire a babysitter for the weekend for her 3 children. She has 2 choices. Babysitter A charges $10 per child and $5 per hour, and babysitter B charges $15 per child and $2 per hour. So at what point will they charge the same amount of money? Part A says we need to a write and solve a one variable equation to find the number of hours for which the 2 babysitters will charge the same amount of money. We're going to let X represent the number of hours. So babysitter A. Babysitter A is $10 per child, $5 per hour. So one thing that you need to make sure you know and you can identify is what is the X and what's the Y. And it actually tells you here. X is the number of hours, right? It says right there. Does it tell us what Y is? I don't think I see it anywhere. So Y is actually going to be the amount of money. So A means that our amount of money this is costing is going to be $10 plus $5 per hour. And I actually just messed that up because it says Susan has 3 children. So it's not $10, it's going to be 30. So you can think about how I got 30. It's $10 per child and there's 3 children. Okay, so I had to do a little extra math for that. The 5x is $5 per hour. This is why it's important that you know x is hours, because it says $10 per child, and I know that some students might interpret that as 10 times x because it says per child. Babysitter B, let's do a different color here. The cost for babysitter B is going to be $15 per child. Remember, it's 3 children, so that's going to come out to $45. And $2 per hour. So what we need to do here is we want Y to be the same. Because remember, Y is the cost. It says find the number of hours for which the 2 babysitters will charge the same amount of money. Same amount of money, which is Y. And if we want it to be the same, that means, so this is a little hard to explain. If Y is, let's say, 100, and this Y is also 100, that means this part, 30 plus 5x, is equal to this. You see, they're both equal to Y, which means I can actually put them together and say 30 plus 5x, right? Y is equal to that. And Y is also equal to 45 plus 2x. So I can write them equal to each other because they're both equal to Y. And so I end up solving this. So I'm going to subtract 2x from both sides. I'm also going to subtract 30 from both sides to get rid of that 30. And I get 3x equals 15. And so x equals 5, and that's 5 hours. So we're going to write a function for each babysitting service. I actually did that already. It's right here, up here. There's A and there's B, right? We're not going to worry about using a graphing calculator. You could take a look at that screenshot they have of a graphing calculator on the bottom right. It shows that the 2 graphs will intersect. I asked that the first 4 problems of the homework assignment that you also sketch a graph so you can see that they will intersect. That's important to it's an important observation to make when we're looking at two functions together. And then we're going to use a table here to find that intersection point. So we're going to let f of x be babysitter A, and then g of x be babysitter B. So we're going to look at or refer to the functions that we have up at the top to determine our outputs here. So if oh, and by the way, remember that this is our cost and x is our hours. So at 0 hours, babysitter A is going to cost $30, right? $10 per children. And babysitter B is going to be $45. Okay, so I'm going to actually fill in all of the column for babysitter A first. It's just going to be easier to focus on it because if the slope is 5, it's $5 per hour, I'm adding 5 every single time. So this is $35. 2 hours would be $40, then $45, then 50, then 55, and 60. Okay, then babysitter B is $2 per hour. So I'm going to add $2 every single time. And so I get 47 for 1 hour. For 2 hours, 49. Then 51. Then 53. Then 55. Then 57. Okay, adding 2 every single time. And you'll notice that at 5 hours, we do have the same cost. The babysitters are charging the same thing. A table is really nice because we actually see not only the x value, when they end up being the same output, we actually see what the output is. When we did the part A, we only saw the amount of hours that they'll be the same cost. And so here we can see that at 5 hours, both babysitters are gonna charge $55 each of them. Okay, let's look at the next couple pages. Page 311, the your turn. It says Sarah would like to hire a clown for her daughter's birthday party. Clown A is offering his services for an initial fee of $100 in addition to $11 per hour. Clown B is offering her services for an initial $150 fee in addition to $8 per hour. When will the two clowns charge the same amount of money? Use a table and a graphing calculator to estimate the solution. So we're just going to use the table here. No graphing calculator required. Clown A, initial fee, and so actually let's identify. X is the hours, number of hours specifically, and Y is the amount being charged. So this means the amount being charged is going to be $100 plus $11 per hour. Clown B is a $150 fee plus $8 per hour. So let's do a table here. Going to do a 3-column table because we have one input, that's our hours. And we have 2 different outputs because it depends on which clown, right? Clown A and then clown B, the cost. Put $sign here. So this is our output Y. All right, so in 0 hours, clown A is $100, clown B is $150. In 1 hour, and 2, and 3, and 4, and 5. We can keep going if we need to. Be flexible with your tables if you need to add to it. So clown A, $11 per hour means that 1 hour it's 111, then it's 122, and 133, and so on. Okay, let's stop at 5 hours for now. I don't know if I'll need to keep going. Clown B, $8 per hour added on top of the 150. So 1 hour would be 158, then 164. I did that wrong, sorry. 166, and then 174, 182. Oh, I will definitely need to keep going. What is that, 190? Okay, let's keep going here. 6, 7, 8, 9, and 10. So 6 hours. Let's go back to clown A again. Again, I'm going up by 11, so that'd be 166, 177, 188, 199, and let's see, 11 plus that would be 210. Okay, let's go back to clown B. This would be 198, 206, 214, I think, 222, and wow, they don't give us a whole lot of space here. And then 230. And so when you notice, I'm probably going a little bit too far by ones here. You can actually skip some hours if you really want to. So if I go to, let's say, 15, for example, so I'm going to show that I'm skipping some here and do a different color. 15. This just means we got to do a little bit of math here. Clown A would be 11 times 15, which is 165. And then if I add 100 on top of that, right, $100 was our y-intercept, that's 265. For clown B, if I did 15 hours times 8, let's see, that is 120. 15 times 8, 120, plus 150 would be 270. And you can see I'm getting there. I'm close. 16 hours would be I'm adding 11. 276. 17 hours would be 287. And 18 hours would be 298. And then for clown B, 278, 286, and 294. Okay. So I think we've reached some sort of solution here. So take a look at this. 16 hours. Yeah, this is very difficult to see the solution here. At 16 hours, clown, which one? Clown B costs more than clown A. But here, clown A now costs more than clown B. And it's gonna stay that way because clown A charges more per hour, right? So that means that somewhere in the middle of 16 hours and 17 hours, they will charge the same. Okay, so now we're estimating the solution because it actually tells us estimate the solution here. And so it could take some time to find it, skip some numbers if you need to, just like I did. And so we're gonna say something like both clowns will charge the same after about 16 hours. So something like that. Okay. Our next example, our last example, in fact, is going to be the your turn number 8. Cassandra has $2,000 in a bank account that she uses to make automatic $900.01 mortgage payments each month. If Cassandra stops making deposits to that account, when would automatic payments make the value of the account 0? Use a table to estimate the solution, then use a graphing calculator to approximate the x-intercept. This gives us our context that is sometimes a little difficult to understand, but there's a bank account Cassandra has this much money in a bank account. And it's important to note that she stops making deposits to that account. So deposits means we're not adding any, she's not adding anything to this account. She is making automatic payments, automatic $900 one payments each month. Okay. This means that if she's making payments each month, she's using her money that's in her bank account. So think about what's happening to the balance of her account. It's going to be going down. So it's going to be decreasing. So let's go ahead and we need to make a table to estimate the solution. The solution for 1 is the account going to be 0. And then we're going to use, no, we're not going to use this. We're not going to use a graphing calculator. Don't need to do that. So think about what our x-intercept, so what our x would be and what our y would be. Our x, our independent variable, is the number of months. And our y is the amount of money. It's really the money left in the bank account. So if x is 0 months, y is $2,000. And this is going to be a little bit ugly only because this amount, $900.01, that's not totally unrealistic because some mortgage payments, even card payments, are some very, random amounts of money. So something like, I believe my car payment recently has been like $262.27, something like that. So they're always gonna be some sort of odd amount. But because $900.01 is so close to $900, we're just gonna use that because the 1 cent really is not gonna make that big of a difference. If it was much further away from 900, I would be a little hesitant. So after 1 month, if we subtract 900, there's going to be 1,100 left. 2 months, there's going to be, how much? 200 left, right? And 3 months, there's not going to be enough money. If they try to take out $900 from the bank account after 2 months, it's going to be it's going to be in the negative. Really, it's going to be overdrawn. So we want to know if y is 0, what is that x value? I should have used a different color here, sorry. If y is 0, we want to know what that x value would be. And so it is going to be about 2 point something. And so I'm okay with you just mentioning that after 2 months, the account balance will reach 0 or will equal 0. And that's $0. Okay, so some of these problems are a matter of estimating or at least being able to communicate, right? To write that sentence explaining the solution, especially if you don't have a straight, simple answer, you'll be able to you'll want to be able to write that out and be able to explain it. Okay, and that's it for this lesson. I hope it was helpful. Thank you for watching. Have a great day.